Let's look at legendary polynomial. So this is a polynomial which come under a class of legendary polynomial, and if we solve this differential equation, and I will get a class of polynomial which will be called as legendary polynomial. If we can rewrite this equation in the form of like this, then we'll get p of x and q of x, and we know that singular points will be plus minus 1 and every other point will be ordinary point. We can use the power series at x is equal to 0. Because x is equal to 0 is ordinary point. Yeah, because if we put x is equal to 0, limit will not go to infinity. We can use the power series method. If we use the power series method and then differentiate it twice, then put it in a differential equation, and we take the common value, then we're going to reindex this first term because everything need to be x to the power m, right? Or x to the power k, not m, x to the power k. And after combining this term, coefficient we get them to 0. We equate them to 0 and we will find the coefficient value at k plus 1, and this all related k plus 2 to ak. So odd term will be 0. Odd term will not be 0, but you can find the odd terms. So Legendre polynomial, if n is positive integer, one of the series terminate polynomial solution. What they are saying is, if n is a positive integer, then one of the series will terminate. If n is even series terminate. If n is odd series will terminate. Because this is even series, this is odd series. Legendre polynomial are normalized. P of n of 1 is equal to 1. The first few are P of 0 is 1, P of 1 will be x, P of 2 will be half 3x squared minus 1, and like that. And when n is equal to 0, then P of 0 of 1 is a naught, which is equal to 1, then P naught x is equal to 1. And so you can see here that if n is equal to k or n is equal to minus k plus 1, a k plus 2 will vanish. Also, let's see that a k plus 2, right? A k plus 2 is k minus 1 and k plus n plus 1 and k divided by k plus 2, k plus 1, ak. What I am saying is if n is equal to k, so if n is equal to k, this term will get 0, so k plus 2 will be equal to 0, so it will finish. And if n is equal to minus k plus 1, if n is equal to minus k plus 1, then this term will get 0 and k plus 2 will get finished. So they're saying a k plus 2 is indicative of the series getting terminated with ck as last non-zero coefficient. That is how we get polynomial solution. While obtaining polynomial solution, we use n is equal to k conditionally. If we take n is equal to minus k plus 1, the series diverges for x plus minus 1. The solution is unbound and is called the Legendre function of the second kind. So Legendre polynomial, this is the note how we can write this at term n is equal, if n is equal to 2n minus 1, 2n minus 3 up to 3 to 1, then divided by n permutation, you can write it as 2n permutation divided by 2 to the power n permutation whole square. Legendre polynomial of the first kind, when n is equal to k, we can write it as like this. And there is our generating function. The expression of this Legendre polynomial can also be generated from a function of two variables, say x and t. When expanded in power of t, the x dependent coefficient defines the Legendre polynomial. Consider g of xt is 1 minus 2xt plus t square whole minus whole to the power minus half. We can write it as summation n 0 to infinity p of p n x t to the power n. Now if we expand this 1 minus t to the power t 2x minus t whole to the power minus half, and we will use the binomial expansion, and then we will get this term, and it will be obvious from this equation is that after expansion we will get 1 plus xt plus half 3x minus square, and on equating this coefficient of t, and we will get for first n is equal to 0 1 2 3, p naught x will be equal to 1. So first term is 1, then second term is x, third term is half 3x square minus 1, and fourth term will be half 5x cube minus 3x. Now the coefficient of tn in this above expansion will be like this. But before that, some notes. Now generalized binomial theorem. What is the generalized binomial theorem? So 1 plus z to the power alpha will be equal to k 0 to infinity alpha k. This is the combination, and z to the power k. Now this series converges for mod of z less than 1. And alpha k is nothing but alpha minus 1, alpha minus 2 up to alpha minus k plus 1 divided by k permutation. Because it is like what about 3 and 4? So no 4 and 3. So 4 minus 1, right? 4 into 4 minus 1. So this is like 4 permutation. So 4 minus 1, 4 minus 2, 4 minus 3, and 4 minus 4. Divided by 3, 3 minus 1, 3 minus 2, 3 minus 3. So for integer alpha is equal to 1, if alpha is an integer, this reduces to standard binomial coefficient n k. Now for non-integer alpha, such as series is infinite series. So for example, 1 plus z square. So this will be nothing but 2k z to the power k, 1 plus z square. So for alpha is equal to 2, for alpha is equal to 2 integer exponents, it will become 2 0 uh, z to the power 0, then 2 1 z to the power 1, 2 2 z to the, so these are the coefficients. So remember this, the binomial expansion is from alpha to k, but what we are trying to define is not only the binomial expansion or not only the binomial coefficient, but also the expansion of this formula, where the binomial coefficient will get involved, and we will get like 2 0 means what? So 2 permutation divided by 0 permutation. It's like uh, 2 permutation divided by 0 permutation and 2 minus 0 permutation. So 2 minus 0 is 2 permutation and 0 permutation is 1. Then again in uh, up also 2 permutation, so it will be 1. Then next 2 1, so 2 permutation, then 1 permutation is 1, 2 minus 1 will be 1, so answer will be 2. Next key point, this series terminates after k is equal to 2, because 2k of this combination term will be 0. Now if alpha is equal to half, then we'll see what happens. So half 0 is 1, because since by definition alpha 0 is 1, so alpha 0 will get 1 for any value of alpha. If alpha 0 is there, then this should be 1. And half 1 will be equal to half 1 and half, right? No, because the formula will get different. So this formula will be half minus 1. So it will be formula will be half minus 1, half minus 2 divided by k permutation. So k is 1 permutation and this should be half only. Then next, half 2, so half minus 1 divided by 2 permutation. Then half minus 1, half minus 2 divided by 3 permutation. So 1 plus z to the power half will be uh, go up to infinity. Now if alpha is equal to minus 1, 1 plus z whole to the power minus 1, then we can just write the summation term, and then we can expand and we will get the coefficient. So that's it. Now, so binomial theorem for any two terms a and b, binomial term can be written as a plus b whole to the power k is equal to summation m0 to k, km combination a to the power k minus m b to the power m, where km is the binomial coefficient for any term like minus 2x plus t minus 2x t plus t square whole to the power k. So it will be m0 to k and coefficient km minus 2xt whole to the power k minus m and t square multiplied by t square whole to the power m. So we can expand the generating function using this binomial series. We can take this as like 2x minus t square is less than 1, and then 1 plus z square alpha we get from 0 to infinity alpha k is z to the power k. So alpha k will be like alpha minus 1, alpha minus 2 up to alpha minus k plus 1 divided by k permutation. And here z is minus 2x t plus t square, like alpha is equal to minus half. So this is not an integer. So this is an infinite series. If we do this, we will get half from minus half to k and minus 2x t plus t square whole to the power k. So first term, so 1 minus z square is already done. What is 1 minus z square? Because 1 to the power k minus 1 will be just 1, right? So it's only, well, just write b to the power, b to the power n. So that's it. So after that we can just expand this form and generating function become k0 to km 2x. Why it is becoming km? Well, you can expand this 2 minus 2xt plus t square k. So after expanding this, we will get what? 2x to the power k minus m, and then t to the power k plus m. And we will get the value summation half to k, then summation k to m 2x minus k minus m t to the power k plus m. Here m runs from 0 to k, and coefficient of this like this. And collect the term where power of t is n. To do this, we need to determine all combination of k and m such that k plus m is equal to n. So here we can see clearly that m runs from 0 to k, right? So the exponents of t is k plus m. Now coefficient of t is k by coefficient km minus 2x k minus m, right? Now collect the term where power of t is n. We need the term where power of t is n. Now to do this, we need to determine all the combination of k and m such that k plus m is n, or m is equal to n minus k. Now since m must satisfy uh, 0 to m must be less than 0 to k, because substituting m is equal to n minus k given n minus k must be in between 0 to k. So first inequality we will get k is less than n, second inequality we will get like this. So combining these two, k must be less than in between n by 2 and up to n. So k must be an integer where we take the ceiling of n by 2. K range from n by 2 up to n. So this means that this maps the real number x to the smallest integer greater than or equal to x. Like 3.2, so it can be 4, some minus 1.7 is minus 1, right? Because the smallest integer greater than 3.2 is 4. This is what we want. So we need some k value greater than n by 2. So we will take this as k greater than n by 2. So this is, we can write it like this: 2x t 2x t k minus m t to the power twice m, right? Here one thing was missing, t was missing. Well, t was not missing. What I did write it as like uh, k plus m. I write it as k plus m. So here it was 1t. So here it was 1t. So I took it and I write it as 3 to the power k plus m. Now exponents of t k minus m plus twice m is equal to k plus m, right? We want the exponents equal to n because we want k plus m. Yes, k plus m we want equal to n. K must be integer. We take the smallest integer k such that k must be greater than n by 2. So this is nothing but carries integer function, the ceiling below. This must be valid. So this is nothing but m must be less than equal to k and greater than equal to 0. If we solve these inequalities, we will get so avoiding 0 term is in summation if k less than 2. Case 1, if n2 is even, range of k 1 to 2. So for k1 it will be minus half k2 1 by 3. So for p2x will be half 3x squared minus 1. Okay. So why not start at k is equal to 0? m is equal to n minus 0 because n minus k to n 0 n greater than 0, so we cannot do that. So now we write the generating function like this, and we can substitute the value. K n minus k and n minus k. So 2k minus n, right? This should be equal to p of n is nothing but so the coefficient of Tn is in g of x, this generating function is p of n. Tn, we will remove this Tn, we just took the value 2x k minus m, and we will put m value as n minus k, then we will get 2k minus n, then we will get summation k n by 2 up to n half k and I will change the variable. So from where we get this equation, the coefficient equation, this coefficient. Well, we already know that in order to the value of the k range from n by 2 up to n, right? So this is what we got. And then second thing what we got is from this equation minus half 2k the expansion, which is nothing but minus half k. This was we got minus half to the power k 2k minus 1 combination, then 2k k combination. If we substitute this value minus half, this will be our the expansion for this minus half k. This is same. Then k and minus k, this is already defined, k and minus k. Then minus 2x, yes, already. Now change of variable for clarity. So we will do some changing of variable. We will take s is equal to n minus k. We will take n minus k as s. Then k will be n minus s. Then this n minus k will be s. Then n minus s will be k. So summation limit become s equal to 0 to s is equal to n by 2. Now substituting this value, when k is equal to n by 2, right? S is equal to n minus n by 2. So if n is equal to 2, then 2 by 2 is 1. So s is equal to 2 minus 1 will be 1. So if k is equal to n, then s is equal to what? N minus n, because integer value, if n is equal to 3, then 3 by 2 is 2. So 3 by 2, 3 minus 2 will be 1. So it become n minus n is equal to 0. So s from this value will be 0 up to n is equal to n minus n by 2. Now simplifying, n is equal to twice m even value, n by 2 is equal to twice m by 2 will m. So s is equal to twice m minus n by 2 is just m value. For odd value also m. The maximum value of s is n by 2 this function, and then in both case upper limit is n by 2, and then we can write it as like if we do this, then as 0 to n by 2 minus k value is n minus s, then 2k value is n minus n, so 2n minus 2s in both upper and lower side, and then k value is n minus s, so n will be cancelled only, and remaining will be s, then 2 to the power x to n minus 2s. And double factorial is like there is a equation with twice n minus 1 double factorial will be twice n single factorial 2n n factorial. Can convert it to standard factorial. So minus 2x and minus 2s is nothing but half to the power n minus 2s, 2 to the power n minus 2s, and x to the power n minus 2s, right? And twice n minus s minus 1, this will be equal to twice n minus 2s single factorial divided by 2 to the power n minus 1 n minus s and n minus s factorial. And substituting this value in p of n, pn of x, we will get what? We will get this value, and if we simplify this denominator, we will get like this, to the power twice n minus 2x, because this will get combined. And after this, we already know to the power minus 2x to the power minus 2x, one, we can write it as like this. So pn of x will be like minus 7 minus s twice this combination. Then again we can combine the minus 1 terms, right? Minus s and minus n minus 2s will be 2s and minus 3s. So minus 1 to the power minus s. Now if we combine these two exponents, 2 to the power minus twice s, 2 to the power twice, it will become 2 to the power minus n. And you can substitute this value and we will get what we are going to find this Pn of x. Comparing p0, we can substitute this summation from s0 to 0 by 2 will be equal to 0. If we put this, it will become 1. This time will be 0, so 0 means 1, and to n will be, x to the power n, this time will also be equal to 0, s will be 0, n will be also 0, s will be 0, so 0 combination 0, 1, 0 combination 1, 3 to the power 0, 1 is, so we can compute all of this like that, p1, p2, p3, p4,